All right, video number 3 for week 9. This is it. This is the end of it here for week 9. So I got 2 new concepts to introduce, mass percent and then dilutions. And then I'm going to go through some sample problems from your homework for chapter 9. All right, page 1 of our notes, right? Mass percent. Mass percent is the mass of solute divided by the mass of the entire solution times 100%, okay? Fairly straightforward. If it's mass percent, we're talking about masses. The grams will cancel, and our answer is always in 100%, is in percents. I'm going to do an example problem for you right now, but just to reiterate, solution is the solute and the solvent all together, okay? Don't forget that. So, example, 4.50 grams of CaCl2 is used to make a 10.64 gram solution of calcium chloride. First question says, what's the mass of the solvent, water? Well, we take the mass of the entire solution, 10.64. We subtract the mass of the calcium chloride solute, and what we're left is the mass of the solvent, 6.14 grams H2O. Now, B is actually totally separate from A, even though it might not look like it. It says calculate the mass percent of calcium chloride in the solution. And they've given us everything we need in the introduction to the problem before A. 4.50 grams of solute divided by the entire solution's mass, 10.64, times 100%, and we are left with 42.3% calcium chloride. So the solution is 10.64 grams, and the calcium chloride is 42.3% of that mass. Next topic, and we'll do more mass percent problems later on, but dilutions is our next topic. Dilutions. We're just going to learn this one by doing a straight example. There is the equation in your book. My equation is slightly different and probably a little easier to remember. Here's the example. You have a 16 molar HCl solution that's very concentrated. You have a 16 molar HCl solution. How would you produce 2.0 liters of a 1.0 molar solution? Well, the dilution equation is M1V1 equals M2V2. And I don't care which one is the concentrated side, which side is the dilute side, it doesn't matter. What does matter is the M1 matches up with the V1. And it said, what volume of 16 molar solution? So we know that the unknown goes with the 16 molar. So I have 16 times X equals 1.0 molar times 2, or 2.0. We solve for X, use sig figs, we get 0.13 liters. Now what does this mean? Well, it means if we want to make a 1 molar solution, we're going to have to use just a little bit, 0.13 liters of the really concentrated stuff, and then dilute with water until we get our volume of 2.0 liters. Okay, that's what that means. So you have to understand what these mean as well. So when you get a volume of 0.13 liters, you're going to take a small amount of really concentrated stuff, dilute it all the way to 2.0 liters, and that's how you get 1.0 molar. All right, now here's just some random chapter 9 problems. They're all very helpful. Some of them are not assigned problems, and that's not because they're different. I just want you to have more exposure to more problems from the chapter. So this is number 34. Calculate the mass percent for the solute in a solution, A, containing 75 grams of NaOH and 325 grams of NaOH solution. So they're telling us that 325 grams is the mass of the entire solution. So it's mass of solute divided by mass of the solution times 100%. We get 23% NaOH. Not 23%, but 23% NaOH. Don't forget that, okay? So we also want to calculate the mass percent for the solute in a solution containing 2.0 grams KOH and 20.0 grams of water. Note that it says 20.0 grams of water. Water is the solvent. The solution is a KOH solution. That's why my denominator here is 22. So the solution is the 2 grams of KOH plus the 20 grams of water. 2 divided by 22 times 100, 2 sig figs, 9.1% KOH. All right? Next problem, number 46. Looks like it's number 46C, actually. It says calculate the molarity. Molarity is moles per liter. Calculate the molarity of a solution containing 30.0 grams of NaOH in 350 milliliters of an NaOH solution. Well, since molarity is moles per liter, the very first thing I need to do is convert grams of NaOH to moles of NaOH. I can do that in one step using the periodic table. If I add up NaOH, add them all together, it's 40.00. That 30.0 grams of NaOH divided by 40 gives me 0.75 moles of NaOH. That's going to be my numerator, right, for moles per liter? So 0.750 moles of NaOH all over, not milliliters, but 0.350 liters of solution. If I do the math, 3 sig figs, 2.14 molar NaOH. Okay? Next sample problem from your homework is 48A from Chapter 9. We want to calculate the mass of solute. So we're looking for grams. Calculate the mass of solute needed to prepare 2.00 liters of a 6.00 molar KBr solution. So they're giving me molar, which I know is a mole per liter, and they're giving me a liter. So I see a roundabout way to get to moles. And if they ask me to calculate the mass of solute, they want the mass of KBr, which I can get from moles of KBr using the periodic table. First, I need to get to moles. So 2.00 liters over 1 times the molarity, but written as 6.00 moles KBr over 1 liter gives me 12.0 moles KBr. Now I just make that, I start with what I'm given, put it over 1, multiply by the molar mass of KBr, I get 1,430 grams KBr. KBr weighs 119 grams per mole on the periodic table. 1 K and 1 Br weighs 119. All right, next page of our notes here, 50C. It says, calculate the milliliters of a 2.50 molar K2SO4 solution to obtain 1.20 moles. Well, I know that milliliters I can find if I just have liters. And I got molar. Big M is a mole per liter. So look at the units that are built in here and then situate them. So I've got moles. If I put that over 1 and divide by the molarity and then multiply by 1,000 milliliters over a liter, I end up with milliliters. Follow the units. So 1.20 moles of K2SO4 times 2.50 moles of K2SO4 on the bottom, 1 liter on top of solution. That puts me in liters of solution. The next step is for every 1 liter, there's 1,000 milliliters. Now I'm in 480 milliliters of solution. Okay? All right. 56A wants us to calculate the final concentration. See that word final? That means there was also an initial, right? Initial concentration. A catchword like final or initial makes me think of dilution. Before, after, initial, final. Calculate the final concentration of 1.0 liters of a 4.0 molar HNO3 solution being added to water so that the final volume is 8.0 liters. So I'm just reiterating here, words like final and initial, obviously a word like diluted or concentrated makes you think of the dilution equation. M1V1 equals M2V2. I got my 1 liter going with the 4 molar, so 4.0 molar times 1.0 liter equals my unknown M2 times the new, more dilute volume, 8.0 liters. The molarity is 0.50 molar HNO3. Not just 0.50 molar, but 0.50 molar HNO3. Don't forget all your units. All right, 58B looks like it might be another dilution, even though they haven't even written the problem. Determine the final volume in milliliters of a 0.10 molar HCl solution prepared from 25 milliliters of a 6.0 molar HCl solution. All right, so what to do here? Well, the 25 is grouped with the 6, so there's my either M1V1 or M2V2, it doesn't matter. M1V1 equals M2V2. I got 0.10 molar times V1, my unknown, equals 6.0 molar times 25 milliliters. Note, if my V2 is in milliliters, my V1 is going to have an answer that's in milliliters. I could have also used liters for V2, but my answer to V1 is also in liters. Okay, it's something to be said for here is the significant figures. I had 2 sig figs, so my V1 is 2 sig figs, 1500 milliliters. All right, so you've got everything you need for Chapter 9. We had 3 videos. Make sure you watch the videos, and then you rewatch them slowly while taking notes, and then make sure you understand your notes. And the same thing with the homework problems, okay? All right, see you next time.